Hey, Precalculus, today's lesson is on average rate of change, functions that are increasing and decreasing. This is how we define average rate of change. We'll look at the change in y over the change in x. You might just consider that as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Average rate of change is the same thing as slope. Today we're going to give it just some different values. We're going to give ourselves a couple coordinates. The x coordinate will be A and the other x coordinate will be B. That means if we have a function, our y value will be f of A and our other y value will be f of B. Therefore, if you write the average change, our second y value, x's, here's our y's, our second y value would be whatever f of B is minus f of A divided by B minus A. And that's how we will define average rate of change. So it's really the same thing we've done in terms of slope. We're writing it a little bit differently. I'm going to draw a generic function here. And suppose you wanted to find the average rate of change between 2 points. I'm going to go between these 2 points right here. The average rate of change between those 2 points is the change in y, which is in this case 1, 2, 3, 4, 5 units down, divided by the change in x. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the average rate of change is -5 over 9. Let's do some basic problems. Determine the average rate of change of the function between the given values of x. F of x is equal to 4x minus 3. We want to determine the average rate of change between these two values. So what I want to set up is get my two coordinates, -2 and 4. So I have A and I have B. The question is, what is f of A? If you plug in -2, 4 times -2 is -8, minus 3 is -11. Sorry, I sneezed. F of B, be 4 times 4, which is 16, minus 3 is 13. So the average rate of change is f of B minus f of A divided by B minus A. Positive 24 divided by 6 is 4. 4 is the average rate of change. Same thing for the second function. I have -2 and I have positive 1. But I do not have my f of A or my f of B, so I plug it in. 3 times -2 is -6. -2 squared is 4. -6 minus 4 is -10. 3 times 1 is 3. 1 squared is 1. 3 minus 1 is 2. F of B minus f of A divided by B minus A. 12 divided by 3 is 4. You can see in both cases I come up with answers of 4. That is just by chance. Last year people joked and said, can we just write down 4 every time? No, you can't. So now you should be able to do average rate of change problems. Next question is identifying intervals on which the functions are increasing or decreasing. Increasing means the average rate of change is positive. Decreasing means the average rate of change is negative. Or the graph is on its way up for increasing, on its way down for decreasing. So you can see this blue section here. The graph is on its way up. It is increasing from -5 to -2. After that, the function begins to decrease. It decreases from -2 to +2. In between here, the function is neither increasing nor decreasing, as the rate of change of the function is 0. After that, the function begins to increase again from 4 to 5. For the next example, I have arrows on this one. So it begins increasing way back here at -infinity, all the way up until -1, -2, -3, to -3. Then it begins its process of decreasing from -3 to +1. Then it continues to increase from 1 to 4. And after that, it has a slope of 0. That is neither increasing nor decreasing. You should also be able to look at your calculators and understand where functions are increasing and where they are decreasing. Let's graph both of these and see what happens. One of my y equals x to the third minus 9x. I'm going to zoom standard so we can all see the same window. Where is this function increasing? Where is it decreasing? I'm going to increase my window slightly. I'm going to go to y values of -20 and +20. I have scales of 5 just so I don't have so many tick marks. A little bit better view of my graph. If it helps you, you can sketch a little graph right off to the side. It will be increasing blue marks and decreasing red marks. So we need to find those transition points. They happen at what we call maximums and minimums. This is a max, this is a minimum. You know how to find those on your calculator. Second, calculate maximum. I move over to the maximum. Left of that spot, enter, right of that spot, enter, enter on guess, -1.73. Minimum, second, calculate. Go down to minimum. Enter. Let's move our cursor down to our minimum. Move to the left of that spot, enter, move to the right of that spot, enter, enter on guess. 1.73. So we can now answer the question. Increasing from -infinity to -1.73. Decreasing from -1.73 to 1.73. And then increasing, so union, 1.73 to infinity. That answers the question. My next function is a little bit trickier. This is our last example, then you can get to work on your assignment. -2 I'll go into math, grab my cube root, and we've got x minus 3 plus 1, and my parenthesis then plus 1. Careful about that. Examine my graph. I'm not in a standard viewing window right now. Kind of a strange graph. I'm going to zoom standard, zoom 6. Maybe see it a little bit better. As you look at this graph, I'll sketch it on the side. Oh, sorry. It's rather interesting. Is the graph going up or down as I move along the blue? It's slowly going down, okay? And so in fact it's decreasing. And then, even in the red, you can see that the function is still decreasing. In fact, it looks like it's always decreasing. Only there's a slight problem. If you were to look at the slope at all those points, there's one spot where it looks like for just a split second, the graph does go straight up and down, vertical, right at that spot. The graph goes straight up and down as you look at the calculator at that spot, ever so slight. It actually happens at just one point. I know it sounds silly that you can have a graph where the slope can be calculated at one spot, but that is the magic of calculus. And this is just a little bit of introduction to it. As you look at the calculator, as you look at the value 3, you can see that there's about 4 or 5 pixel marks stacked on top of each other. It does give us an indication, as I'll even zoom in on it so you guys can see better what I'm looking at. Go over this spot right over here and zoom as a box. Yeah, you can see it just goes straight up and down for just a split second. That's a really good view of it. And the question is, what is the slope of a vertical line? Maybe you remember this. That line is positive, that line is negative, that line is 0, but that line has an undefined slope. So not only is it neither increasing nor decreasing, it's not 0 either at that spot. So we have no increasing, so increasing, none, but decreasing would be from negative infinity to positive 3. We would not include 3 because in fact the slope is undefined at that one spot. If that's confusing to you, we could talk about it later. But there you go. There's your introduction to increasing and decreasing functions and average rate of change. Your assignment, section 2.4, page 182. Please do numbers 1 through 6, 15 through 20, and 27 through 32. Thank you.